So hello all of electrical and computer engineering, some of which are also from SOC as guests who were invited yesterday for the welcome tea. So today we'll be learning about Godot. As you have signed up and as I've said, Godot is a game engine which allows you to create games on your own. And what makes it different from the other types of game engines is that it's in its simplicity in prototyping, and also its ability to be able to be very user-friendly to anyone who is new to programming. So what this workshop will cover will be allowing you to be able to use the game engine rather quickly and to be able to be as broad as possible. So I'll show you as many features in Godot as possible. So this workshop might be a bit fast, but don't worry, you have two assistants over there who will be allowing who you can direct your questions to. Okay, so let me give you a brief introduction of Godot. This will be the slides. They aren't necessary for you to learn about the game that we'll be making, but we will be talking about what is Godot and how it compares to the other game engines. So I created this chart about the other two game engines that are quite popular in the market. These two game engines are called Unity and Unreal Engine. These two are industry standards and game engines that is being used by companies to make different types of games like Genshin Impact and other like It Takes Two, and also another game that was quite bad, it's like Refactory 5. Anyway, as you can see, both of them are free, but what differs in Godot is that it's free and open source, which means that you can access any of the open source code to check whether or not you want to be able to improve the game engine, be able to fit your needs better. Compared to the other two, Godot is a very light engine and allows you to prototype much faster with its fast compile speed. The game engine, as you have downloaded, is very small in size and allows you to allows you to move it around many different laptops. Even the smaller laptops, which aren't very powerful, can even run Godot. However, Godot might not be very supportive in its community, as its community is still developing. The amount of assets on the store is not as much, and so you might want to consider Unity or Unreal Engine moving on if you want to do game development for real. But if you want to just delve into it and see whether or not it is fit for your career or perhaps your interest, then Godot is the perfect engine for you. Okay, so Godot uses a node-based architecture, unlike Unity, which might be a bit complicated to me or to some others who might first get started on programming. And it also accepts a bunch of multiple scripting languages. The one that we will be using is called GDScript. It's a language that is being used only in Godot. However, its syntax and its method of programming is very much like Python, as you will see later on. Installing Godot is very easy, as you have done before coming to the workshop. And exporting your game to different types of formats like .exe and Android formats will be also very easy, as you can do from the links that I provided in the downloads page. There are also many different types of tutorials that you can use and to be able to find out what different types of games that you can make using Godot. With that, I have come to the end and we will start making our game immediately. Okay, Junyang, could you take the laptop and answer any questions there? Yeah, sorry. Okay.
Recording in progress.
So, there's one question on how to get this project started up. So this will be the base project that I've provided to you. In the repository that I have posted on the Telegram, it will link to my GitHub and the repository I posted there. What you can do is three things. First, you can download as zip, which is what you usually do on most GitHub pages, repositories. You can click on the green button at the top right, and there will be a button called download as zip. This will create a static project that you can open up, and when you use Godot, how you open it up is something like this. So usually you open the Godot game engine, and it will lead you to a bunch of projects. For you, it might be empty, but first you need to scan for any projects that you have. Now, where you clone that repository or might have downloaded that zip folder, you have to go to that folder and you have to scan for that current folder to see what projects there are. So for me, I clone the project into Godot under my documents folder. And these are all my Godot projects. So when I clone it there, the folder named after the repository, GDG, ECE, Godot Game Development Workshop will be there. Now, if you select this current folder and it will scan for all the possible projects that I have. The one you'll be looking at will be the GDG ECE Beginner Workshop. And once you open that, then you'll be directed to this blank screen. What I have provided for you in this project is the bunch of assets that you need. So if you look at the assets folder, you'll notice that I provided a bunch of fonts, sprites, background images, tiles, even Stephen Hudden's face, and a sprite sheet with all the different sprites for characters that you might want to use, as well as the audio.
Brandon,
Yes.
Can you what's that? I can't seem to open your repository. I need to sign up to GitHub first.
Oh yeah, so do sign up for a GitHub account. This is required for most people who want to do game development. However, I believe that you can just download a zip even without a GitHub account. Yeah. It's on the Telegram group. Yep. In the announcement page, I have linked the repository. Okay. So this should be the screen that you'll be having at first. Okay. Once you're here, then you should know that we can get started on the project. So as I have provided a Godot handbook that shows you the different interface options, what you'll be greeted with when you first open Godot will be a very nice interface for 3D. However, we won't be doing that. To switch from 3D to 2D, what you want to do is to click on the buttons up here. This is called your viewport. There are 3 types of viewports you'll be interested in, or more like 2, because you won't be doing with 3D environments. You'll be dealing with 2D and the script. Script is where you'll be doing most of your programming, and 2D will be where you'll be editing most of your scenes. Now, you might be asking, what are scenes? Scenes are a collection of objects. This is our purpose of doing this workshop is also to teach you some programming concepts such as objects. And Godot and games in general will be very good in helping you understand what these are and what the hierarchy of game objects are. On the left, we have the scene tree. So first order of business will be to create the character. Now, most of the time you won't use these 3 buttons, you want to use the other node. Now, what happens here if you choose the other node is that you'll be greeted with all the possible nodes in Godot. What a node is something that is an object that comes with a bunch of pre-built properties, such as the position, the rotation, and the scale for 2D objects. However, if you're in 3D space, you might want to think about the depth and the 3D coordinates of the objects instead. So what each node contains is properties, predefined properties that allows you to edit it and to be able to have different properties on it. So what Godot has done as a game engine is to define a bunch of nodes that you will use as a game developer. The first one we want to do and create is the character body 2D. Now, Godot will provide you a description of what each node does. It's a 2D physics body specialized for characters moved by script. You can double click on this and it will create the first node created. Okay. Now, this is the scene tree. In object-oriented programming, the objects have children and objects can also have parents. In Godot, when your game is started up, it will have a root node, much like how a C program has a main function. This root node will contain all of the objects, and in the hierarchical structure, it will create many of its children that serve different purposes, such as the map. And when you have a map, you have different platforms inside the map as children of the map. Okay, on the bottom left, we have all the files that was imported when you cloned the repository. And on the right, you have the node inspector. There are 3 tabs here, but first we will take a look at inspector. The inspector tells you what properties are within this node. This node has special properties based on character body 2D. So what all these headers do, right? They're telling you these properties under here, they are all specific to the character body 2D. So what that means is that if you have all these properties, is specific to only this character body 2D. Next, we also have some other objects, some other headers that are here. You'll notice that this node is colored blue is because it's specific to 2D, which means that it inherits the node 2D. Every blue node inherits this node 2D, which means that it contains the information of a node 2D. And what is inside node 2D? It has transform. You expect a 2D object to have the 2D coordinates, x and y, the rotation in degrees, and the scale. These three, rotation, translation, and scale, provide you the spatial manipulation to allow you to move the object in any position. Then you also have skew, which is something that is usually done for 3D. Okay. You also have canvas item and other nodes that allow you to describe how it's going to be portrayed and rendered onto the screen. But let's not talk about that. And let's get on to creating your first character. In the 2D space, before you even get to any programming, we want to make sure that this character has an appearance. What you usually have for appearance will be PNG files, which are image files. What we want to do is to get the character sprite. Now, I'm going to create the character sprite. And if you take a look at the folders I have provided for you, you would have seen a player.png. Now, this is an AI generated image. And once you drag it and drop this sprite inside, it will be automatically placed into the scene. Now, what I want you to do, just a little something, is to rename this as sprite. Okay, I rather prefer it that way because it will help me to explain things better. But you notice that this sprite is a bit too big. So what I want y'all to do would be to change the scale of this sprite. In 2D manipulation, and when you're changing a scene, you want to make sure you adjust everything to what you deem as correct. In this case, the sprite is a bit too big. What I can do is to press Q. This whole thing is your toolbar. In the toolbar, you have a bunch of different tools to manipulate the 2D scene. To manipulate the 2D scene. The first one would be the select tool. Then you have the three different types of tools to represent the translation, rotation, and scale that you can use to manipulate it. So when you press Q, it will be just like Microsoft Present PowerPoint, and you can control the way that it moves. There are different different modifier keys that you can press to help you and aid you in making this transformation easier. I can hold alternate to make the center fixed. And I can press shift to constrain proportions and make sure that the image does not get stretched. However, all these options and transformations can be done using the inspector. If you take a look at the transform that every 2D has on the right side of this pane, you'll notice that the scale can be manually positioned. What I have just done when I shrunk down this image is that I have scaled it down to 0.5. What you can do is to actually change this to what you would deem fit. I would want this to be 0.1. And this seems appropriately sized for the character sprite that I'll be using. So all of you can set the scale of the sprite to 0.1 and make sure that the position is at 0, 0. This is to make it such that the sprite can be easily manipulated, and that when you spawn any effects on it, it will be at its origin, the center of the object. Okay, if everyone's ready, then we'll move on to creating the shape, the collision shape of this object. This is just an image file, but it does not have any shape to allow it to collide with the other objects. Yeah, Sis? You're rotating it?
Yeah, now that I'm pressing automation.
Okay, so if you press Q, right?
Yeah.
And you select the sprite, there should be the controls on the nine sides of the square. You can drag, and then you can hold alternate, and then it'll be constrained. Yep, so you just need to hold the button. And to prevent you from making the image stretch, you can hold shift to allow it to be constrained proportions. Okay, let's undo that and make it 0.1 by 0.1 again. Okay, next, you'll notice on the left side, there will be this warning that Godot is telling you. This yellow exclamation mark is trying to tell you that this object does not have a proper shape. Okay, it does not have a proper shape. So let's create a shape. There are two types of shapes that you can use, and both of them are considered collision shapes. Now, a shortcut for you to use to create a new node would be to press Ctrl A. That's what I have done. And this will bring up the node screen. Now, this will add the new node as a child of the currently selected node in the hierarchy. Okay, so what we want to search for is the collision. You will notice that there will be two collisions. One is called collision polygon, which allows you to define composite shapes and figures, while collision shape will give you a predefined preset of different shapes like circles and squares. Let's use collision shape 2D. Okay, double click on collision shape 2D. And now it complains again, telling you that it does not have a shape. Okay, so now on the right side, right, you notice that it currently does not have the shape that you want. Let's left click on the empty in the inspector panel on the right. When you do that, you will be greeted with a bunch of different shapes. Let's create a rectangle shape. Now that we have a rectangle shape, we can edit this shape to fit this character. So what this shape defines, right, is your collision with the map. You don't want the person to be facing through walls. So this will define where the boundaries of the body is. To make it fair for your player, you want it to make sense. So what you do is that you try to constrain this box to the player. Now notice that currently I cannot make it move towards the feet. The feet is halfway in between the grid. What I have currently set enabled is called grid snap, which makes it such that it will snap towards the grid. Now that I've disabled this button on the top, this one, I can make the shape form anyhow I like. Okay. Now, most of the time, I want to keep the origin at least in one of the axes. And I want to keep this up here. Okay, don't worry about the cheeks. They can hit the wall for all we care. And if you want to constrain proportions, you can hold alternate again, and then you keep it within the center. Okay, sorry, keep it within the center. Yes.
Constraint is it like this?
Wait, sorry, can I help? Yeah. Okay, next, we'll be moving on to what saving scenes are. Okay, so in every project, yes? Yeah, I don't need to, because we don't really want to keep it towards the feet. If it's a bit too fat, then afterwards the fabrics have a lot of room. So we want the player to have a bit more versatility, especially in the room that we're gonna have. Oh yeah, I forgot to tell you what kind of game we're gonna make. Okay, so I should address this from the start, but this is the finished game that you can expect. Okay, I'm in the maze of Stephen Hardin, and I know it's a bit trippy, but I just wanted this to be fun. And I have an endless stream of enemies who have navigation. They are using A-star pathfinding and algorithm that is used to be able to navigate mazes, and they are trying to kill me. So I can shoot missiles at them, and they take 10 hits to die. Yeah, but I will take 20 damage if I collide with them. So I don't have a health bar. But yes, and then you die because I put the Dark Souls theme in there. By the way, the reason why this is like M shit looking thing is because I enabled debug mode. I'll show you how I disable that later on. but it's in the editor. Okay, so that's the end. That's the game, that the finished product that you'll be seeing. And I have a copy of the finished game with me to make sure that I can copy the contents over. Okay, so I'll regularly be using GitHub Desktop, and hopefully you can follow along to see how GitHub works. So now that I have committed all these characters, I should be able to see some changes in my repository. If you have added this repository, all your repositories will be here. And my one would be here. Changes are automatically done by Git. Git is an open source software. It's a software that allows you to detect changes within your project. It's a very smart software. So with the changes that you have seen here, I will be able to commit them. So first thing I want to teach you is file management. This scene, it can be saved as a file, and currently it's unsaved. I would like to make my project more neat by naming each node an appropriate name. For example, this is called character body 2D. We don't want to do that. We want to call this a player to make it a bit more clearer. So we'll call this player. Okay, now that we've done that, we can press Ctrl S to save your scene. You'll be brought towards the root of the project. And notice here, you don't have actually a scene folder. So what you want to do is you want to keep your project organized. Let's create a folder by clicking on the top right. And call this scenes. Small case, because that's the convention. Okay, so you can press Ctrl S on the scene to be able to save the file. You'll be brought to the project root, where all your files and folders will be. You press the top right to create a folder. Okay, wrong one. To create a folder. And with that, you create a scenes folder. Enter the scenes folder. And you want to create another folder to organize. You have many different types of scenes, mobs, maps. So what you want to do, you want to organize it to be only the player scenes. So you can create a folder called player to keep all the scenes regarding the player inside there.
I don't see those scenes.
Wait, help. And when we press Ctrl S and we have the file, then our player scene will be automatically placed. It is also lowercase because that's a convention of all files. Okay. So now that we have saved it, we have the So you have to. Your guy has to be impressive one. Not click again, rename a phone, no. Then also press F2, which is the hotkey to rename. Yeah, it's okay. Okay. Now that I have saved the scene, you'll notice that in GitHub Desktop, 10 change files. Git has recognized that I have added new files and has recognized the changes. What I'm going to do is that I'm going to commit such that everyone, even the people at home, can follow through. If you're lost and you feel that you're completely away and like stray from what I'm going through because I might be going too fast, you may git pull, which is something you can press here later on. And you can collect all the newest changes so that you can be kept up to date. And then you can follow along after that. Okay, so I'll do a git commit and I'll just summarize what I've done. I've added a player scene without the script. Okay, I'll commit to main. Now, I have committed locally on my own computer. Now I want to tell GitHub that I've had those changes, so I'm going to push. Once I push, the cloud, the GitHub servers in America or something, will receive that data and they'll now update the website GitHub with my changes. Now, anyone who uses git pull and refreshes the origin by pressing this button, because all of you are pullers, whereas I'm a pusher. If you are puller, you can fetch origin to refresh, to check with the server in the database to see whether or not there are changes. And once you press this fetch origin, you see that there's a button called pull that allows you to pull the latest changes. However, you do not need to do this if you feel that you're on track and that your project works. If your project does not work, you might need to download it just in case you're completely lost. Else we will fix it for you if we have enough personnel. Anyway, that's a rundown of Git. I'll be regularly pushing updates just in case people are lost. Okay, next, you can actually create and play the scene. By pressing this run edit scene, you see that the person's bottom right is there. Why is it like that? It's because the whole viewport, which is where your screen is defined by this purple square and rectangle. I just think I always hate this thing. Anyway, I wish I can disable it. Okay. Anyway, yeah, this is the whole thing. You'll be able to play this scene locally later on, and we will first talk about a hierarchy of the scene of the game. Okay, let's do this a bit quickly. You can press this plus button on the top. Okay, I'm gonna press this plus button. It's at the top, and you'll create a new scene. It has not been saved yet. So you create a new scene. We'll create another node, and we will create this gray node. Okay, it will be this gray node. What does this mean? It means that I'm creating this object that is completely useless. Okay, this object has nothing. This node is the base node, is the parent, is the ancestor, is the parent of the parents, is the parent of all objects. And it doesn't have any properties because all the children who inherit it, right, will have different types of properties that is added onto what is inherited. Okay, so why am I creating a useless node that has no properties? Well, it's just to act as a container to be able to add scripts to it later on. Okay, so what I mean is that I will now have the main node over here. Just like in C programming, you have a main function, and in the main function, you have a bunch of functions above it as a preprocessor to be able to call those functions above it. And if you imagine the call process is a branch, a tree that calls different types of functions and processes. So we have a main folder. Okay, now that you have renamed the main, you'll save it. If you press Ctrl S, you will save the scene again. I can move up to the scenes, and I will create a new folder in under scenes called main. Okay, and I will save it here. Yep.
Okay, about scenes, right?
Yeah, so under scenes, you create a new folder called main, small letter. Okay, now we'll do the exact same thing, but now we'll call this game. Okay, why am I doing this? It's because if you notice in bigger projects, in large game projects, they follow this pattern whereby they create a main and then they have a game. What the game is going to be a 2D scene. So finally, you can press this blue button called 2D scene. Okay, 2D scene. Now I'm going to create a 2D scene. I'm going to rename this game. Okay, same thing. I'll press Ctrl S to save the scene. And I'll do the same thing, just like just now. Okay, let me refer to my hierarchy in my ground truth, just to see what I've done. Okay, never mind. All right, and I will save this under main. Okay, you don't need to create a game folder. You may, it's up to you actually, but the way I'm going to do it will be to create it under main, because a game scene is just a main. It's under the main hierarchy of scenes. So I'm just going to save it right next to main. Okay, so you notice in most games, right, the way that you do it is that they'll have the main scene, create all the processes, such as all the different types of frameworks, the functions. Then they have a game scene that renders everything. So that's why we have a game scene and then we have a main scene. Usually, you have the game scene be an instance under main. So now I'll show you what is instancing. If you right-click on your main scene, where all your projects will be, you can instantiate a child scene. Okay? Now you'll be presented to all of the scenes that you have created in the past. You also can press Ctrl-Shift-A. It's different from Ctrl-A, whereby you're instancing a scene. You can press Ctrl-Shift-A and you'll also be brought to the same thing. Okay, now we want to instance the game scene. Okay, so what is instancing? It is to create the instance, the copy of the object of the node. So this game, right, is actually just a template. I have a bunch of stuff I can put here, but it's not actually in the game scene because it's not actually in the main scene where the game is going to be played. We'll create a copy based on this template. And in the main scene, with the child of the game, it will copy all of its properties. So let me demonstrate what I mean. Yes.
So how do you make the child of the game?
You can press Ctrl-Shift-A on the main scene, or you can right-click and there will be a button called Instantiate Scene.
Okay.
So let me demonstrate what I mean. You don't have to follow through, but what I'm going to do is I'm going to add a rubbish node. I'm going to call it the color rectangle. What this is going to do is that it's going to create a fat white rectangle in the center in the full. Hold on, let me see. Okay. Oops. What happened? Okay, never mind. Let me do something else. Let me just put this player in the center. This is a big flat player. You don't have to follow through, by the way. Okay, so I'm going to save the scene. I've edited this game scene. And as a template, this game scene will have this character in the center of it. Now, I saved this scene already. If I go back to main scene, you notice the exact same thing. I did not touch the scene, by the way. So that means that when I instance the game scene, every change to this game scene will be seen in the main scene. Because the child is a child. So this is just a template. You can even click on this little button called Open an Editor. You click on this and you'll be brought to where it originates from. Yes. Yes, that's right. So if you make changes in the children with the parents who have those children will have those changes because they are instantiating the child scene, and the child scene has been changed. So the child scene has mirrored the changes from the template, which is the game scene.
On the game scene that is affected.
Sorry, can you repeat that?
Okay, so if we make changes, this scene will not affect in this scene.
In the main scene, yeah, it will not affect the game scene because the game scene has no dependency on the main scene. Okay, so let me undo what I've just done. If you want to redo it in Godot, you press Ctrl-Shift-Z, which is the proper way. It's not Ctrl-Y. I don't know why Ctrl-Y is the thing. Okay, so now I'll show you what is game instancing. Now, we'll make our first script. We'll control the player. Okay, so this is rather simple. It does some vector maths. Okay, just a little bit. What you want to do is to create your first programmable script. It defines the behavior of this node. By pressing this script button, this scroll, you can create this movement. Now, to show you this for this screen, let's create the template first. Okay, we'll just leave everything as default. Don't need to touch anything. And we'll press create. Now, what you have just done is created a script with a template. Godot developers have given you this template, and you did not type this. This is behavior to define a platformer game. We're not doing a platformer game, so you can actually delete this. But what this has done is that it's provided you a useful reference to what a game script can look like. This is what is defined in the game script. Okay, if you notice, if I play the scene, okay, this is harmless, by the way, you can just play the scene anytime. The character will fall. This is reminiscent of a platformer game, whereby your character will fall at 9.81 units per second. Okay, and you can define here, there will be gravity. Okay, so you notice that the speed which is moving is 300. The gravity is by this. So you might see all these different types of settings. And looks like my screen is not that good at presenting the thing. So let me show you another thing. You can edit your editor. This is specifically for you. You can change your editor to whatever disgusting colors you want. But mine is quite disgusting because I chose all the saturated colors. If you want to, you can go to editor settings. On the top left, the editor settings are here. This is specific to you. You go to editor settings, and you find the text editor. Under the theme, I changed all the colors to match the colors I like. Okay, and for you, it is very bad for you to see because the number is too blue, and therefore you cannot see. So I'm going to change it to a different color, a lighter color. Oops. Okay, there we go. Okay, this color is a bit lighter. Okay, so now you can see that the color is okay. Okay, so this is the script. Now let's delete all of this. Or you can comment it out if you want to, because you might want to reference. And we'll do the first step to creating the top-down method of moving. Okay, so the first thing you want to do is, I'm going to use my reference here, is to create the speed. This will be a constant variable. Okay, I'm going to increase the font size so you can see it better. This will be a constant, something that you don't want to change, and it'll be the speed, much like what the person did just now. I want to move at 300 units as defined. It's an integer, but we want to make it a double, a floating number. Okay, so 300.0 will tell you it's a double. Now notice that this is just like Python, you don't need to specify the type. However, it is implicit, which means that you don't have to say it explicitly. It will know that if you put a 0.0, you're taking in a floating point number. Whereas if you don't have this 0.0, you would be taking an integer. It also does typecasting very easily. Okay, next, we want to define the, let me see. Okay, something like, okay, next you want to define what is the movement. Okay, so in Godot, just now you noticed that in the template, we have a bunch of functions that allow you to move, to allow you to predefine functions. The first of which is something very important called physics process. This is what I mean by Godot is a real-time programming language, more like real-time computing they call it, which means that it's something like what you learn in EE-2026, whereby you will program an FPGA. It's a field programmable gate array. And that mod is very tough for a lot of people. But in that mod, you will be creating reprogramming on the board that runs code every 60 millihertz, in 60 millihertz, which means that it will run very fast. That kind of programming is called real-time programming. And similarly, in games, you might have heard of something called 60 FPS, which is 60 frames per second. This function called physics process. If you type phi, physics, you already have been prompted what's going to be typed next. Physics process delta. This is a built-in function. It did not define this. It did not write this. Okay, zoom in even more. Okay, good. And I can, okay. There we go. There we go. Okay, here. So in physics process delta, this will be a built-in function. Now, you don't really have to care about delta for now. It's just the amount of time that has taken place between two frames. In other words, it's compensating for lag. If you're running a very crappy computer that can't run 60 FPS, then there'll be some lag. And that amount of time in milliseconds taken between two frames will be called delta time. Okay, now let me teach you something very useful that will help you avoid a lot of questions for you. It is called control click. Okay, control click. Click, control click. You hold the control button and you click. You click on most things and you'll be brought to what it means. What this brings up, right, is the whole documentation. You have the whole documentation offline, which is amazing. That's why I like Godot a lot. It's because if you want to find out about something, you can just control click and you'll bring up the documentation. So you might find this kind of documentation a lot when you go to internship and a lot of different types of jobs, requiring you to use frameworks that you might not know. Similarly, this one allows you to have a documentation of what this function is. So whatever I said about delta is defined here. Delta is in seconds and is the time taken between frames. Okay. And this function will run every frame. It runs 60 times per second. So what we want to do, right, is that we want to calculate the vector in which I'm moving when in every frame. So let's have the arrow keys define your movement. Okay, I'm not using WASD. It's a bit too confusing for now. Okay, let's have the arrow keys defined. Up will be, okay, so left will be -1x. Okay, -1 unit in the x direction. Right will be 1 unit in the positive x direction. And up, can you tell me up? If I press up, how many units in the y-axis should I have? Wrong, -1. No, why? It's because the y-axis in many game engines is inverted. Okay, positive y is downwards. And that's why when you go to your game engine, right, most of the time you'll be actually working in the bottom, the fourth quartile, or the fourth quarter of the Cartesian plane. Where am I? Where the hell am I? Okay, yeah. That's why the viewport is here. So that means that when I move this guy down, right, you notice that the positioning is positive 26y. Okay, I'm going to control Z. And I'm going to go back to my script. Okay, so knowing that, you want to make sure that your directions match that. And similarly, when you press down, then it'll be positive y. So let's define a bunch of inputs that you'll be pressing, and that will define the direction you're going in. Okay, let me see. Where's my input? Okay. Oops. Input and well, sorry. Yes. Really? Oh, okay. Then Unity is making some more sense then. Anyway, so let's define. So we can use a bunch of if statements that you learn in CS 1010. So the function that will define the inputs and it will take in the inputs that you have, right? It's called input with a capital I. Why is it capital? It's because it's a class. A class are defined as a capital letters. Okay, sorry, wrong one. Input. Okay, it's the second option here. It will be colored green for me. It might be colored a different color for you because it is a built-in class. Now you can press dot and this will tell you what kind of actions it is. So it is action and there'll be a bunch of Boolean functions for you. This one you want to say is action just press. Actually, no, it's action pressed. So if you hold it, then afterwards that button will press, will keep running. Now you have a bunch of different suggestions here. These are all the text, all the buttons that you can press. That's fine for right, to move in the right direction. Okay, so I need to press the inverted commas, and I need to type in right. Okay, the only option you have here is UI right. Okay, now I'm going to be lazy and I'm going to copy this. So what you want to do, right, is that you want to define what is the direction. So I want to make my velocity. This property velocity, right, is also built in. Where can you find it? It's actually in the player scene. There's actually a velocity within the character body. So this character node, right, character body 2D node, has the property velocity. So I'll type in this velocity. And then I'll say that the velocity is going to be in the upwards direction. So velocity. Oh, wait, sorry, no. Vector, sorry, I'm saying wrong. Vector 2. Now there's a lot of vectors. Vector 2 is a 2 vector, so it only has 2 numbers. Vector 3 is for 3D. It has 3 numbers. So I'll type vector 2. The first number is going to represent the positive direction. It's the x direction, and the second number is going to represent the y direction. As you can see from the constructor template here, this is a constructor and it tells you the arguments that you need. However, you can also use enums, which are defined by Godot. So if you actually control click, it's really useful. You'll notice that they will give you a whole documentation of what you can put in. One of this is the constants that it has. Up, down, left, right are here, and they define for you 1, 0, or that. So I'm going to choose, and I'm going to show you that you can actually, instead of pressing 1 and 0, 1 and 0 to represent the positive x direction, you can actually just press, dot, and it will give you all the constants that is defined within this class. So I want to put right as a constant. Okay, now you'll be thinking, I can move in all 4 directions. I'm going to duplicate this line 4 times. So what I'm going to do, I'm going to do this 4 times. Okay, UI up, down, left, right. Okay, this seems very disgusting to me, because right now what you're doing is that every frame you're checking 4 things at once just for movement. It might be very taxing for your computer and the processor, especially if your project is going to become very large. So what you want to do is that I want to do this other method. So what I'm going to do is going to comment this out. You can keep it for reference. And I'm going to show you another way. Okay, this other way is going to be about the input vector. Okay, and it is going to be method 2. In method 2, I will have something called a variable input x. Okay, I've defined a new input x. Okay, this is a user-defined function variable, and this variable, newly created one, will be based on the input action strength. Okay, so I'm going to show you a new function called input get action strength. Input get action strength. Now, if you don't know what this means, you can always control-click and find out what it means. But basically, what it does is that it takes the direction of what you're going to define here. I'm going to say UI right, which is the right button. And it's going to be, hold on. So if you're using a controller, right, you have a joystick. And if you move towards the right completely, that'll be 1. But if you move it halfway, it'll be 0.5. So what this does is that it allows you to be more versatile with your controls. But for here, we're just going to say is the amount that you're pressing. So if I'm pressing right, it'll be 1. This function will return you 1. If I'm not pressing it, it will give me 0. So what does it mean is that I can actually define the input vector to be 0 if I'm not pressing anything, 1 if I'm pressing right, and -1 if I'm pressing left. Okay, so this is the amount of UI right I'm going to input, and this is the amount of UI left I'm going to input. Minus these two, and you might get 0, you might get 1, and you might get -1. So this is a very easy function for you to quickly get the amount of x-axis that you're controlling. So input dot get action strength UI left. Okay. Now you can duplicate this line by pressing, okay, no Control D, by pressing Control C on this line, and then pressing Control V. And then you can change this to Y. To change this to the Y axis instead. So I'm going to make this. So the left one will be the one that is positive, such that when it minus the right one, it will be positive if it's bigger. So this one will be downwards. And this one will be one on the right. Input dot get action strength UI up. Okay, also right now it's complaining about something. Expected indented block. Oh yeah. Okay, so in Python, indentation matters, so you need to indent these two. Okay, such that it is part of the function process delta. Okay.
Yeah. What does the get action strength mean again?
So you can control-click and it'll give you a definition of what it means. It basically tells you how much of this button you're pressing. If I press it like really damn hard, then it's gonna give me a 1. If I'm not pressing it at all, it give me a 0.
Okay. How when checking everything 4 things at once? How does only check 2 things at once means?
So this one, right, it actually doesn't give you an if statement. If statements can be a bit costly because it actually does check manually. But this one, it just returns you a value no matter what. Sometimes it doesn't matter if it's true or false. It just returns you a value 0 to 1. Okay?
What's the shortcut for commenting?
Commenting? Oh yeah. So to comment something is very useful. It's not Control S, Control slash, it's Control K. Don't ask me why. It's very annoying. Got Control, it's Control K. Okay. Okay. Now I have the input X and input Y. If I'm pressing right and up at the same time, it should return me this is going to be 1, and this is going to be -1. It's going to return me this line. And this line is going to be 1 in the positive in x and -1 in y. So that means that I'm moving in the top right direction. But do you notice something wrong about this? Let's say I want to make my gauge there. I want to move in a direction as the fastest speed of 300 units. That means if I press 2 buttons at once.
300 root.
Yes, that's right. I'm going to get cert 2, which is cert 2, which is 1.41 something.
Yeah.
Okay, and that is faster than 1. So if I theoretically, if I press 2 buttons at once, I'm going to move faster than if I press 1 button, which is unfair. Okay, so what I have to do is I have to make sure that this is part of here. In other words, you're going to create a circle. It's like a polar equation, right? It's going to create a circle, and this is going to be 1 in length. Okay, you don't have to do vector next. Godot will help you do it. To do that, you actually just need to normalize it. Normalization is very annoying because you have to take the 1 over cert 2 for the whole thing. So instead, what we want to do, right, is to normalize the vector in total later on. Okay, so first of all, let's create the velocity. With the input that I've given, I want to make sure that this input, which is going to be a range of -1 to 1, multiplied by the speed. Okay, and that will give me my velocity. Am I doing it right? Yeah, I'm doing it right. Okay. Similarly, for the y direction, I'll have the input y, which is between -1 to 1, multiplied by 300. Okay, that'll give me x and y. Now we combine them together. But since this is just the property of the velocity, it's actually already part of the velocity. So what I'm going to get is that velocity, right? This guy. Where's my velocity? Yeah, it already have the x and y properties because you directly change them with the dot x and dot y property. Okay, so the dot, that's what the dot will help you do, especially in vectors. Now, to address this problem, this velocity, right, is actually, you can control click on it. The type it is vector 2. It's a 2D vector. And you can click on vector 2 again, and you have a bunch of functions. Okay, this can help you out in your MA 1511, 1512, 1512. Okay, you have your dot product, you have your orthogonal product, orthogonal, you have the projection, reflection, all those A-level crap. Okay, now what you want to do is that you want to dot normalize. Okay, normalize is a function built in by them. And this will help you reduce anything to be the magnitude of 1, no matter what. Okay, you can even control click on this, and then you can find out that this is what it means. Okay, they'll tell you about it. Divided by the length, which is length being the magnitude. Okay, so now we have the velocity normalized. Now, to make the character move, we're going to do this magic function called move and slide. Okay, you want to move the character. There's a bunch of built-in functions called move. And what you want to do is move and slide instead. Okay, what this does, right, you can control click on it and read, is that it actually takes the velocity that you have just defined and takes the velocity and moves the character based on it. Okay, so it's built in. You don't have to like do some like, oh, I want to take this pixel and I move it here. I want to take every single pixel and move it over there. Okay, this is a game engine. It's supposed to help you. So now I can actually play this current scene. Click on this button, the one with the clipper on top, not the actual play button, because that one will ask you to define the main root function. You can click on this one. And notice I can move. Top right, clipper. Yeah, so you have defined the move function. If you have not done that and you are a bit lost, I'm going to commit it now. Okay, so I've changed 19 files and I'm going to commit. Add player movement with script.
No, I don't have GitHub. Reddit, I don't have GitHub.
Oh, you can download it from the Telegram. Yep. So that one is easy because the purple icon one, it allows you to not install Git on the command line.
I already downloaded it. Now I just do it on Git.
Okay, and I'm going to push. Okay.
I downloaded it.
Now you can test it out. You can even remove this line if you want to. You can command this out, command out this line. You can play and you can find out how unfair it is that you can move faster just by going top right, bottom right. Yeah, oops.
Email address. It can be the email address can be the right?
Okay, as a bonus, you can even make this simpler. Okay, if you don't like what we are doing with the movement here, like you say, I don't like these 5 lines, you can do method number 3. Okay, I can comment this out and I'm going to do method number 3, which is another function. Okay, so if you take a look at what this function does, right, it creates a variable direction. And this direction is a vector2 type. Its x will be something called input.getAxis, which is basically input get strength UI right minus input strength UI left. Okay, you can even control click on this and it'll tell you exactly the same thing I just told you. It's basically whatever we've done. So it compresses the code even further. And then the y is going to be this. And then I'm going to dot normalize it. Okay. So this line, yeah, this line, hopefully y'all can see is very long. But yep. So it's a vector2 whose x function is get axis and y is also get axis. And it normalizes straight up. Okay, so it just everything together. 5 lines into 1.
Is this more efficient or just shorter?
It's just shorter. It's actually not more efficient. Yep, and then you can velocity is equal to the direction, which is now a vector2. So it's just vector multiplication multiplied by a scalar, and then you get the vector again. Okay, and then you move and slide. Okay, and then what you notice is that this thing is the same, exactly the same. I'm gonna comment again because some people might not be able to follow. So add player movement with method 3. Commit. Push. Now I can get pull if you want to. Okay. Move. Okay. Okay, so now let's instance this player into the game scene. And now I'll show you how to press this play button. Okay, you want to press this nice play button, right? This will need you to instance the main scene first. Okay. So remember in the main scene, we're going back to the main scene now. Okay, I'm gonna go back to the main scene. And we already have instanced the game scene. In the game scene, everything will happen. The map, the player movement, the mobs that are spawned there. And first, in the game scene, I'm going to instance my player. Ctrl-Shift-A, or you can right-click instance, and you're going to add the player. Okay. Now, what you notice is that if you look at your 2D viewport, your player is now inside the game scene. And if you take a look, if you Control S and you save it, am I saving it? Okay. So you press the game scene, you press Ctrl-Shift-A, and then you instance the player. At the top, there's the viewport. You move from the script to the 2D viewport. Then notice that in the main scene, I also have the player because the player is inside the game, is inside the main. And now I want to make my game play from the main scene. So you can press the play button. Okay, you press the play button, and now they're telling you, they're complaining, saying that currently we don't have a main scene to allow you to run the project on. You need one scene to root everything. So now I'm going to select, okay? If you're on the main scene, you can select current. But I'm going to select, and I'm going to select the main scene. Okay, and now you notice that everything works fine. So now you can press the normal play button, and that will allow you to play the game. Okay. Now I want to show you another thing, is debugging. Okay. Yes. Wait, Wayne, can you help me? Sorry. Yeah.
You guys will touch something on GitHub and now nothing goes.
Oh, on GitHub.
Yeah. I'm so sorry. Yes. Because like
And okay, so the next thing I want to show you all is the debugging. So you can actually see what's inside the game scene at runtime. Okay, by doing that, you can go to back to while the game is running, keep the game running, go to your left side, left pane. Notice there's a local and a remote. Remote means that it's going to be running, it's going to show what's on the window that is currently playing. You press remote, this button here, okay, this one. And now you see the roots. This is what I mean by the roots of the project. And the root of the project, I've instanced the main, and inside the game that I've instanced the player. And therefore you can move it. Okay, so that's how a hierarchy looks like. Now you can press this square button to stop the game. It's the same as exiting the window. Okay. Let's move on to the next thing that we want to do, and that is to create the mob. Okay, the enemy. Let's create the enemy. This enemy will be able to hurt you. Okay, first of all, let me commit again. And this time I'm going to commit to add main scene to run on play button. Okay, next we're going to create the enemy. And that also means that our health, Wayne, can you help him? His GitHub got corrupted. You know, it happens to the best of us. Okay, next, we will create the enemy. Yeah. Okay, don't worry. All the changes will always be on GitHub, so you can always catch up. Okay, next we will create the enemy. Much like everything else, we will create a new scene. So you press the plus button on the top, and now we're going to create another node. Enemy is going to be behaving much like a character, a player. You can control the movement, you can give it the velocity, and the enemy will move around much like a player would. To do that, we will create player. Wait, sorry, not player, sorry, character, body 2D as well. Let's rename this, and we'll rename him mob. I would like to rename him mob 000001, by the way, because imagine you're working on a big game. Then you have individual mobs, right? Imagine you have 100 mobs, then this amount of integers or space or bits be able to compensate for the amount of mobs that you're going to create. Okay, much like it, you will also complain about having no shape. Let's press Ctrl A, collision, and give it a shape. But we don't have a sprite to give it. So let's give it its sprite. I will go to my assets folder, go to the mobs, and then I have a mob here. Feel free to experiment with these sprite sheets. They are also free for you to play with. Now, this mob, I want to rename this as a sprite. Please take note of that just in case it screws up with the GitHub. And then go to your transform, make him to the center, and make his scale 0.1 just like the player would. Okay, now with the collision shape, we will create a new collision shape. It's going to be a rectangle. Notice that the shape is behind the sprite. This is because of something called Z indexing, whereby the children at the top will always be behind the children at the bottom. So you can actually switch the positions of these two, drag and put this below, and now the collision shape is above, just for you to see better. Yes.
Wait.
He's over there. Wait for a while, he'll be there shortly. Now I will move this down and make him fit the shape as much as possible. Okay, so this seems appropriate. Maybe his arm shouldn't be given too much leeway. I'll constrain it to the center so it's better. And I'll make his arms not collide with the walls. And make it a bit shorter. So now that it's fit, you can give him the shape, and that's it for the character, for the mob. Now I'm going to save this scene. To do that, let's create another folder in the scenes and name it appropriately, mobs. Okay, with a plural and with small letters. And then I'm gonna save it, mob _001.tscn. Okay, with that, this mob will now be there. Now, the first order of business would be to make the mob kill me. Okay, to do that, define how much damage the mob is going to deal to me, how much health I have, and when my health reaches 0, I will die. Okay, to do that, I will go back to my player script. Okay, I'll be going back to my player script. I will define my health. This health will be a variable, and it will give me, I will say 100 health. I'm going to make it a floating point to make it more precise, just in case I have fractional damage next time. And also, another trick that you can use is something called export. Let's say I want to go to the inspector when I'm in the 2D node screen, and I select the player. I want to change the health from this inspector. To do that, we annotate. To annotate, much like in Java, you have an @ This @ will define to you an annotation. Export is one of the only annotations you can do. And what export does is that it makes it such that this variable health will be seen from the editor. I'm going to Control S to save the script. And when you go back to your viewport and you select your player's scene and node, you'll notice this new, this new variable defined on the right. For health, it's exactly like we defined it, 100. Okay, so that is the export, and this will be the health. Now, let's define some functions to tell me the death state, how I'm going to die. To do that, we have a function called receive damage. And I'm going to pass in an argument. Tell me how much damage I'm going to receive. Okay. Receive damage. Yeah, that's right. So this is how I define the function, receive damage. I'm going to reduce my health by the amount of damage that I have. And if my health is less than or equals to 0, I will die. Okay, I haven't defined the function die. Okay, so let's define the function die. What happens when you die? You cease to exist. People die when they're killed. Okay, and when that happens, you will kill free. What is kill free? Kill free means to reduce elements from the game. I will free the memory inside the game engine and reduce any trace of me, this function, this node, from the game. Why is it queue and not queue free? Why is it queue free and not free? It's because you want to queue, make sure that you want to queue up for the gates to heaven, and then you will then free yourself. If you call free, right, there's another one that's called free. You will say, you will cut the queue, and then you will be like, okay, I want to die first. Okay, that is bad because that will cause the game engine to crash sometimes. Okay, because you are making some chaos, and sometimes the memory might not be available for you to be freed first, and therefore the game engine will crash. Okay, Let me do a sanity check just in case I'm doing stuff correctly. Essentially, child gain damage die. Significant damage die. Okay. Okay. Now, how do I define when I'm damaged? In the game, I am damaged when the enemy's hitbox intersects my hurtbox. These two hitboxes and hurtboxes are areas, and you can define such a node in Godot as well. So I'm going to define my hurtbox. It's going to be an area 2D. In area 2D, also complains about not having a shape. So I'm going to Control A, and I'm going to give you a collision shape. Now, this collision shape, right, is going to be exactly the same as my normal collision. This collision shape 2D is going to define my collision with the walls and the area of the map, the boundaries. This area will define how I'm going to intersect the hitbox of the enemy. In other words, these two areas are different. These two collision shapes are different. However, they take the same shape. In other words, you can do something to sync these two shapes together since they are both the same. And that is something to do with resources. If you take a look at this, right, whenever you see the empty here, is asking, the Godot engine is asking you to create a new resource. A resource is a type of special thing in Godot. It's a type of file that defines a bunch of different things. Various things such as the shape and the PNG or the video. In these cases, feedback. Anyway, I'm just gonna. Okay. In this case, you want to create a hello. Okay. Anyway, in this case, you want to create a resource that is cloned from this.
Wait.
Okay, I think someone is. I need to mute someone. Oh. Okay. Okay. Cool. Never mind. All right. Yes. Hi.
Okay, what's that? Can you go back to the top?
The resource is going to be something that is has an ID and will be clonable. So you want to sync together, right? You can copy. Okay, this copy is a bit elusive. It's down below here. You press this copy, you right click, you copy, and then you go here and you paste. Now, this is does not have the same position because it's a different node. And I'm gonna move this shape down. What you notice is that if I move these two side by side, right? If I change the shape of this one, it changes the other shape of this one. Why? It's because they are copied, they are duplicates, which means that they share the same resource. Copy. Oh, let me see that. And I will move this downwards to match the same one. Okay, so this hurtbox, right, is going to be different. Now, let me tell you something about collision masks. Okay, in collision physics, in game engines, you want to define what a layer is, what kind of layers are present in the collision. Layers are different types of planes in which the collision box can interact with one another. So let me direct you to the area 2D. You go to the inspector and you go to collision. Now you'll be presented with a layer and a mask. Okay. In this case, I exist in layer 1 and I'm masking everything in layer 1. Okay, what this means is that everything, if you hover your mouse over a layer, right, it'll give you a very nice description of what it is. Okay, let me put back my mic. It can give you a nice description of what it is. Everything, as you can see at the bottom text here, object A can detect or contact with object B only if object B is any one of the layers that object A scans. In other words, a mask is something that senses for layers. So that means that if I have object A, this guy is masking layer 1. Okay, masking 1. I have an intersecting object B, a layer collision B, that is existing in layer 1. This means that if I sense an interaction between the two, these two will, this one, A, will emit a signal. This signal is called area entered. Now, let me introduce you to another pane. On the right side, there will be this node. It's a very ambiguous name, but if you click on it, right, it gives you a bunch of signals. One of these signals is called area entered. If you hover your mouse over it, it tells you a nice description of what it is. Emitted when the received area enters this area. Okay? So if an area intersects with me, then I will emit the signal. Now, similarly, if I have an object that is object C and it exists in layer 2, do you think object A will emit a signal? Yeah, it won't. Because it's only masking 1. I'm only trying to search for layers that are in 1, the plane, the existence of 1. This allows, I'm back. The recording has resumed. Okay, so I'm back. Anyway, so that means that if I want A to be hurt, let's say I'm the victim, and this is the culprit. This will be the mob, and this will be the player, such that I can receive damage from mob B. So that means that I need to sense whether or not an enemy's hurt box has intersected with my hurt box. So this will be called the hurt box. So rename the area to the hurt box to be clearer. Yes? Oh, okay. No biggie. Okay, I'm back. Anyway, what I've just done is that I've renamed the hurt box over here to be hurt box. This area to be hurt box. Okay. Now I'm going to define layers. Okay, to do that, you notice that all these layers, right, they are ambiguously named layer 1, layer 2, layer 3. We can change that. To do that, you go to your project and you go to project settings. Okay, please go to project settings. It's under here. And then you go and search the physics. This is a big case, a big setting. Go to your physics. You're dealing with 2D physics. This one, 3D physics. And you have a bunch of layer names. Let's make layer 1 to be the map. Collision with the map and all. You know what? I'll just name it with small letter. Map. Layer 2 will be the player. Layer 3 will be the mob. That means that if I want to damage the mob, right, I want to have the victim be the mob instead. It will exit, it will mask layer 2. And then I shoot a missile that will search and intersect with the body or the hurt box of the victim. That missile will be layer 2, layer 3. Then the mob, which is the victim, will mask layer 3 and search for anyone who is trying to hurt. Okay, so that's layer 3, layer 2, and layer 1. So once I have done that, you search you hover your mouse over them, and you notice that they are appropriately named now. So that helps you a lot. Okay.
So what are the 3 layers again?
The 3
layers.
Layer 1 is, okay, so I can go to project settings. Layer 1 is map. Layer 2 is, okay, can only zoom in at a time. I can try to search for the editor settings to make the scale bigger. Oh shit, again.
Is the second
Okay,
collision shape a rectangle?
This looks quite bad, but never mind.
Is the second collision shape a rectangle? Under her block.
Yeah, it's going to be a copy. So what you do, right, is that you copy the first one and you paste it into the second one. Yep, so you take it here, you right click, and then you copy, and then you go to the second one where you want to place it, and you paste it. Okay. This looks pretty bad, but you know what? Let me change it again. Change the scale. 125. There we start. Okay. So now the scale is a bit bigger. Sorry about that. And now I'll define the hurt box to have the collision to be the victim, right? So now you're going to mask for anything that hurts you, which is anything that is in the player layer. Player layer. Number 2. Okay, so you just enable player mask 2. You can disable the layer because you're not going to be attacking anyone, you're receiving. And similarly, you want to go to the mob, and now you want to create a hitbox. Before that, let me commit add hitbox and what is it? Define layer x. Did I push? Okay. Okay, let me go back. Okay, so what I want to do is that you want to create an area 2D, much like what you've done with the other guy. Create an area 2D, rename this to hitbox, and you add another collision layer with Control A. It's going to be Control Shape. Now, similarly, you want this to be exactly the same as the collision box with the environment, which is the one over here. Okay, so you right click, you copy, go here, you paste. And now they'll have the same scale. So I'm going to move this down because it doesn't have the same position. Oh, come on.
Is it a mob inside which section?
Sorry?
You think mob inside which section?
Mob is layer 3.
No, the file, the C.
It's under a new folder called mobs. Okay, and similarly, okay, I'm going to pause it.
Same.
Yep.
Under C.
Under scenes. Okay, so now I find the collision shapes like this. Okay, for the hitbox, I want the hitbox to be in layer 2, but not masking anyone because you're not receiving anything. You're not trying to censor anything. You're attacking. Okay. Now, I also want to do some cleanup and clean the environment box that we have. So when you click on the mob, right, it will get its physics layer from the immediate collision shape that it has. If not, it is a union of all the collision shapes that it has. Okay, so I go to the physics collisions. And since it's the environment, it's going to collide with the map. So this is going to I'm going to mask the map, whereas the map will be in layer 1. So it's going to exist in 1. And I'm going to sense for whether or not I am in the map. Okay, Control S. And similarly, in the player, we have the collision shape here. We should do the same thing. Both the mob and the player will mask for the map. Okay, we'll define the map later when it is in layer 1. And we Control S. Oops, Control S. Okay. Now let's learn about signals. Okay.
Just one last question.
Yes.
Where should I save the mob?
Oh, so you save the mob in the scenes folder. You create a new folder called mobs, small letters, and then you save it as mob, which is the default name that it gives you. For me, it's mob_001. Okay, let's learn about signals. Signals will allow you, the game is something, a gift from the game engine that allows you to detect collisions and intersections between areas. So in this case, I'm the victim. I am going to sense whether or not an area has entered me. To do that, you double click on the node here and this one. Area entered. That's what you want to look for. Okay. You connect it to the script that is attached to it, because it's a player script. It handles. Okay. And now, oh my god, it's huge. Now you notice that you have a new function that they just created for you. How nice is that? A new function on Hurtbox area entered.
Where get this new function?
So you go to your node, you click here, you click on signals, and you click on this one, double click on this one. Then you connect it back to your script. Now there's this little green symbol over here that tells you that this is a receiver method. They call these receiver methods because they are receiving signals. They are listening for signals, and when they receive a signal, they'll run this function. So what am I going to run when I'm when the mob has intersected with my Hurtbox? You want to damage yourself. But how much damage do I inflict onto myself? Will I know? Well, luckily, you notice that in this function, they have this parameter called area. This parameter will be filled in by an argument that will be passed into by the intersecting body. So this intersecting body, being the mob, has a script inside it. This script has a variable called damage. This damage will define how much damage will be passed onto the Hurtbox when it intersects. Okay, so this area, right, is actually an area 2D. You can actually do this if you want to. It's optional. It's called annotation. So if you're used to C++, or C, or Java with type definitions, this allows you to annotate the type of the area. Specifically, it's trying to tell you that this area parameter is of type area 2D. In other words, it inherits and all the methods and properties of area 2D, including like the, what is it? Okay, nothing useful here, but it gets the monitoring and the priority, which might be useful in the future. So I want to receive damage from the area. Area is going to be a mob. You know that for sure. Only the mob can intersect with you, and you're gonna get its damage value. Okay. Now notice that this time I cannot control click. This variable damage, right, is going to be unseen. You don't know where it's coming from. It's like a black box. This damage is a variable of area that you don't know for sure it's mob, but you know as the game developer and the designer that it will come from the mob. So after we define this area.damage, right, we will change this later on because there's actually a mistake with it. But we'll go back to the mob, and now we will define how much damage is going to be passed on to us. This mob currently does not have a script. Let's give it a script. Okay, so we click on the script button over here and give it its template. So you can actually make the default template and change it if you don't want the template. But if you do and you forget about it, you can actually just delete it. Okay, so this is the default template. All I'm going to do is that I'm just going to have a variable. By default in Godot, all the variables are public, so you can access them from anywhere. And this will be the damage. And this damage will be defined by you. I'm going to say that it's going to be 20.0. So do 20 damage to me. 5 hits, I'm dead. You can also make this an export, like what you learned. Okay. And now, if you Control S and save it, you can get from the inspector, and you notice that when you click on the node, the damage will be here. So you can edit it, you can change it to 30 or anything. That's not from the default. Okay. Now, notice that. Okay. Let me try to crash the game for you. Okay. So in the game scene, right, let's test out our new yeah, Wayne got anyway. So we have going to try to crash the game. But first, let's test what we're gonna do. So we want the mob to be inside the game scene. If you look at the 2D again, right? Okay, we're gonna have the player inside the game, and we're gonna move him to the center. Notice that you have all these buttons here, right? You can actually move it better because you might be struggling trying to get the center. Actually use these guys. You can click on this. This is the move, this is the rotate, and this is the scale. Nicely, they are positioned on the top left of your keyboard. Q is select, W is move, E is rotate, doesn't make any sense. R is, not R, S is scale. Don't ask me why they do that, but they're on the top left and you can easily position them. So I press W, I can press anywhere on the screen, I can just move it anywhere I want. I move it to the center so I can easily see it later. Then I'm going to the mob be instanced into the scene. Same thing, Control Shift A. Control Shift A, and we're going to instance a mob. So the mob is here. E has a hurt box that will damage me. Okay, so but in this test, I should see that when I hit the mob 5 times, then afterwards I will disappear from this world. Okay, because of the Q3 function that we defined. I see. Okay.
So what's the what?
Okay, so let's test it out. If I press the play button, I'll be positioned right here. I can move, and I'm gonna pass by this guy's hurt box. It crashed. Why did it crash? That's because the area that you got right is actually referring to the hitbox. And this hitbox does not have a script. Notice that it doesn't have a script. It does not have the variable damage. That's why it says invalid get index damage on base 2D. It's trying to tell you that there's no such thing. So what you want to do, right, is that you want to get this mob. You're returning this area hitbox, but you actually want the mob 001. So to do that, what you want to do is to do something, a very useful function called get parent. Get parent. Get parent gets your parent. So it gets a parent. I have hurt box. I get parent. I return the player. When I return the player, I search for the variable damage, and it returns me 20. And then I pass 20, the number 20.0 to receive damage. It goes to here. I health minus 20. And then I have 100 health, 80, 60, 40, 20, 0. If health is 0, I die. And then the Q3 runs. Okay, let's test it out. Okay, when the game crashes, there will be this replay function, replay button on the top right, which is best to play. Very nice. Okay, I'm gonna go hit smack. I pass in once, twice, quadruple, quintuple, and I'm gone. Yeah, I'm good. So, there are many ways to edit the way that you can die. There could be an invulnerability timer to prevent you from taking damage so many times. Have time? Yeah, time to do that. Okay. Yeah. So that's a bit unfair. Imagine I have 5 different mobs. Imagine I get gangbanged by 5 different mobs at the same time. I'm gonna duplicate this guy 5 times. 5 guys are stacked, and they are stacked together in one place. Most games, they have something called invulnerability timer. So if I run straight to these guys, I die immediately because I got collected into 5 different hitboxes, and I die. Okay.
Hey, Brandon.
Yes.
For some reason my mark in can't receive. Is it normal or is it? Because he does not have.
Okay, let Wayne to continue that for you. Okay, let's move on. Okay, let's have vulnerability timer so that I can Okay. So the logic of having invulnerability frames, right, is to define a duration in which you cannot take damage. The state in which you cannot take damage, right, could be something you specify as a finite state machine, which is something that you learn in E2026 as well. A finite state machine is a thing that allows you to control different states and ensures that you're only in one state at a time. This is very useful for platforming games. But for now, we'll just do a simple one with only one boolean, one possible state. So we go back to our script. You go to player, and then we are going to define a boolean. This boolean is going to be called can damage. Okay, and if you're new to programming, whenever you define a boolean variable, we always name the variable to be something like can, has, or is. Sorry, this is true. So the initial value of can damage is true. And when I spawn in, I should be able to be damaged. Okay. Now, this damage will only turn false if I receive damage. So luckily, we have the function here. We're going to receive damage, and then we're going to turn it to can damage is equals to false. I cannot be damaged when I receive damage. Okay. And also, to receive damage and to be able to take in, you want to make sure that you can only be damaged. You can be damaged before you be able to take in. So now you complain because of indentation. You can select a bunch of lines and press tab, and then everything will be fine. So we can read the logic. If I can be damaged, I'll make it such that I cannot be damaged in the next frame. I'll reduce my damage, my health, and I might die. Okay, so this is unfair. I'm invulnerable the moment I take one time of damage. To make it such that I'm vulnerable again, right? I want to make sure there'll be a timer to tell me how many invincibility frames I have. Okay, to do that, you want to do a very useful node called timer. Okay, Control A. This will be called a timer. Okay. A timer is a white node. It is not constrained to anything. In the timer, on the right side of the pane, you'll notice a bunch of variables. The wait time is how many seconds it takes for the timer to run. One shot is to tell you that the timer only runs once. It does not loop. Auto start tells you that when the node is ready or has been spawned into the scene, the timer will start immediately, and then you don't have to call a function to start the timer yourself. So this will be 1 second. And then when we take damage, we will not be able to be damaged. And we will take the timer, which we will rename to invulnerability timer. Or you can call it invincibility, I don't really care. Invulnerability timer. And we want this timer to start. One thing you can do in Godot, right, to access this child node that you have, you can do something called get node, but that's a bit troublesome because you have to do it with a passive string. What you can do, right, is that you can do this shorthand called $. $sign allows you to access all of your children nodes. And you can type in vulnerability timer. It'll give you the path towards that child node. Like green for me, at least. Okay. Now this invulnerability timer, you press dot, you can access all of its functions and methods and properties. I want to this timer and then make sure that afterwards I cannot be damaged. Okay, so they'll ask you for a parameter, argument, but you actually don't need to press anything because you already defined the start time to be 1 second. Usually I can add it here. So this start will start. And then I want this timer to tell me that after it has run its duration, I will be vulnerable again. To do that, I just need to set this can damage boolean to be true. I can be damaged afterwards. This can be done using signals. Again, to do that, you select on your invulnerability timer, and then we practice the habit of creating signals. You go press your node, you press on timeout, which is the only signal specific to timer. Click on it, you connect back to your player, and then on the invulnerability timer timeout, which means that as long as 1 second, I will be damaged again. Damage equals true. Okay. Now let's test it out. I remember that I have 5 guys stacked here. I should die immediately. But I didn't die. I took once. Let's wait 1 second. Twice. 1 second. Twice. 1 second. Quadruple. Once again. Quintuple and blink. Okay. Oh, I've successfully created an invulnerability timer. Want to see again? I can intersect these guys and make them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Now, if you want to do a debug technique, right, you can actually go here to your debug. And there's this little function called visible collision shapes. Okay, this is very useful. When you enable this, you should be able to see all of your collision shapes to be blue in color. 1, 2, 3, 4, 5, 6. Now you can actually see how many invulnerability, where's the hitbox and hurtbox. So that's why when I died just now in that previous game, I had the thing. So
wait, how is the invulnerability timer? Wait, where you get the full name?
The full name of the invulnerability timer?
Yeah.
Well, I just did it with a what's it called? I Control A to add a timer. Then afterwards, I will have the timer. Yeah. I think I ear rape all the people in Zoom. Sorry. Okay. Anyway, we can actually add, make that screen today.
Okay. The only problem is that what is I can't keep track.
Keep track.
I can't keep track.
Okay, wait. Anyway, to help me. Okay. Let me hold on. Let me commit. Okay. Add damage and death. And I forgot to push. Okay. Okay. The next thing we'll be doing is use UI, which will be all the green nodes. Godot also has a bunch of stuff that allows you to do UI. Typically, if you want to do UI, you'll probably be making a website and you use HTML. And then you define where each element is in the markup language, which is very painful. I hate HTML. So what you usually do in those languages is that you define where the position is. Similarly, in user interfaces, in Godot, you define where the position is. Okay. Now, this is actually simpler than you think. The making of a scene, you actually just press this plus button. You create a user interface green node. Okay, this is a green node right here. Now it's going to be called control. We'll call this game over screen in Pascal case because it's an object in the class. Okay, and we're going to add a color rectangle. Okay, this time it's gonna work because unlike just now, it's actually gonna be bound. Okay. Oops. So this color rectangle has spawned. It's currently white in color. I want it to be black, just like in Dark Souls. I can press this new button. This thing is highlighted in yellow because it's special to control node. Control nodes are handled differently from all the other blue nodes and white nodes. This one allows you to define and have a preset to where it's going to be. You can make it the top right, you can make it the top, and you can make it spread throughout the entire viewport. Your viewport is the purple bounds, remember? In this case, we will spread it towards the entire thing. And we go to the inspector and we set the color to black. The Godot gives you RGB and HSV. To make it black, you can go to HSV, or you can take the tedious path and make red, green, and blue 0. But you can go HSV and you can set the value to 0. Okay, if you know color theory. Okay, now it's a black screen. I'm going to add text in the center. To do that, to add text, you do something, you add a node called a label. Control A, label. And this label will be the text. This text is at the top left. I want to make it the center. You know what to do? You make it to the center using the presets. Then I'm going to add some text. It's going to be called Unite. And this text is actually centered on the top left. Let me show you. If I select the label and I spread it across, it's going to be centered on the top left. So I want that. I want it to be on the middle. So horizontal alignment, which is where the text will be, should be center, such that it's the center of the horizontal. And on the vertical, it will also be centered, just like in Microsoft Excel. Okay, so now when I move this, it will spread towards the center. And I can make this bigger. So make sure that when the zoom out happens, it's going to expand and have enough space to expand. Okay. Hold on. Then you died, right? Dark Souls uses some Times New Roman looking thing. So to give it its font, right, I've provided you some fonts in the art folder. Okay, I like Deja Vu serif. And so I gave this font to you. You also can use like anything. If you want to add a new font, by the way, you can, if you're on Windows, you can actually just type fonts and then you can just drag and drop all the TFF files. If you want, here, and you can just right click and you can show in folder and you can drag and drop it. That's for you to experiment. Okay, now under theme overrides, that's where you define the theme of the style of the text. There are colors. The font color I want to make would be red. So I make this red. However, the value is very low. So I can, where's that? Okay, yeah, this is red. And I just make it red, and now the text is red. Okay.
Anyone?
Then under the fonts, right? I want to enable a font for it. This font looks damn ugly. So I'm going to take the Deja Vu serif. I'm not going to take the bold one. I'm just going to put and drag it and drop it into here. Okay, you drag and drop a resource from your folder into the font. Now you zoom in and you notice that it's in this nice serif font. Okay, this can be useful for if you're going to do a project and you want to like make a fancy animation. Godot can help you. Even though you're not going to make a game, Godot can help you in your school project. Okay, next, this font size is damn small. I want to make it like 64. Okay, this looks nice. But I want to make it such that it zooms out and it has sound effects. So in the game over screen, right, this label will zoom out. To do that, you use animations. Okay, this is going to be useful if you want to do animations. This will now be a purple node. A purple node is an animation node. Type animation, and you're presented with a bunch of animation nodes. I want is an animation player. An animation player is very special. It's one of the things that allows you to make things move in the game without actually coding. In the animation pane, right, this is the bottom, the two bars. Okay, you have now a new function called animation. Not really a function, more like a tool called function. You have no animations. Let's create one. You press this button and you click new. Name this animation game underscore over, like a variable. Yes, then you'll be presented with a timeline. If you're familiar with animations, then you have onion skins or like different frames. Similarly, you want to make your animation, this animation when you died just now, 1 second long, and it makes it such that the scale of the font increases within that 1 second in a linear interpolation, meaning that it takes from the 64 size and it's going to scale up to 128, for example. And then it's going to fade away, which means that its transparency is going to be from 100% to 0%. To do that, you want to make sure that the first frame of your animation will be the default value. When your animation tool is up on the bottom pane, notice on the right that you have a bunch of keys here. What these keys are keyframing. Keyframing allows you to freeze that property onto the timeline. It's a very useful thing. Also, you have to type it into the animation track. So to do that, what you want to do is that on the first frame, right, I want my you died. Its font size is gonna be 64. You press this key, okay, and you're gonna create a track. What happens is that this font size is now tracked on the animation player. Then, because it's a 1 second animation, at the end of the 1 second, move my slider to fast forward to the first second. So after 1 second, I want it to have a different value. I want this font size to be 128. Okay, I press enter and then you see that it's bigger. I'm going to keyframe this and make sure that now I have 2 diamonds on the timeline. These are 2 different properties at 2 different frames of the animation. However, you notice that this does not look nice. Okay, it's just black and then black like this. Okay, this is discrete. In other words, it's taking values that are discrete values. You want it to interpolate between these 2 values. You can interpolate it linearly. To do that, there's this property on the track that defines that this is discrete. You want it to be continuous. Okay, I've defined it to be continuous. Now, you notice that when I slide the slider, it takes a value of anywhere between 64 and 128 in a linear interpolation. Okay, but that's not correct yet. I want this color to be red at first and then fade away to transparent. So at the start, right, I want the font color to be red. So I create another track at frame 0. And at the first second, when it's finished, it should be transparent. To make it transparent, you change the alpha value to 0, and it will be blank. Okay, so I change it to alpha value. I can press enter. Wow, because it's lagging. Okay. And then it's transparent. I keyframe it. Notice that it has this nice color gradient from red to emptiness, transparent. So what you notice is that this is also linearly interpolated, and you notice that this thing fades away from small to big, opaque to transparent. And finally, to top it off, you want this animation to start immediately when the scene has been instantiated. Okay, so I auto start, and I don't want it to loop. There's this loop button here. I don't want it to loop. So it'll auto start, and then when I play the scene, right?
Hey Brandon, can you please slow down, please?
I'm running short on time. Sorry, I need to go. I need to present it fast. Wait, sorry. Yes, it's being recorded. Yes. Second track is called theme override. It's actually not important because what you want to do, right, is that you take your slider to the first frame, the 0. You press the key. Now this track, right, is going to be the color track, the font color. So the first frame is 0. 0, 0, 0. And then next, when you go to the first second, it will be 0, 0, 0, 0, 0, 0, 0, 0, alpha. Okay. Then we will save the scene, and this folder will be user_interface. Okay. I'm running short on time, and yeah, we'll overrun a bit, but I will promise you that we'll have a game over screen by the end of this. Okay, next. So now I can play the scene using the clipper play button, and then you notice that the animation plays. Okay, beautiful. Next, what you want is for this to have a sound. Sounds are very easy in Godot. You just create a new audio. Don't be called audio stream player. You have 3. You have 2D, you have 3D, and these 2 vary with distance. The further you are from the source, the softer it will sound. But we want it to sound as loud as possible. And sorry for the Zoom people just now. Okay, so we want an audio stream player. You can take in any MP3, OGG, WAV files. I have included for you a audio file in the user project. It's going to be called You Died. I use YouTube download to strip this away from the video. So you can drag and drop it into the audio player. And Jesus, is going to be this very loud. Okay. I am going to set the decibels to lower because I feel very guilty just now, to minus 14 or something. softer. Ah, jeez. Minus 50. It's still damn loud. Okay, never mind. Anyway, this is the normal one. I'm gonna put this to minus 15. And then something else. Oh, it's not even playing. Okay. Sorry, it's not playing because it hasn't been set to autoplay. So you want it to autoplay. Okay, take on the autoplay and then it will start with the scene. So you can press this now. Okay, can. Okay, next. We're almost finishing. This scene has done. Okay, now we just need to instance it to the game scene when you die, and then it will be bravo done. Okay, so to do that, you have to copy and get a scene that's stored onto your user interface, instantiate it, and then place it in the scene. To do that, it's a new technique called scene instantiating. So you go back to your game scene where you will monitor that you're dead. And then in the, okay, sorry, go to your player because your player is going to die. Go to your player. And now we're going to create a new variable called game over scene or game over screen, sorry, game over screen. Notice that this variable is named in Pascal case because this is going to be a packed scene. In other words, this variable is going to store the template. It's not actually going to be there in the scene. It's going to store a template only. So you have it as game over screen. And now you're going to create this, you're going to load this scene from the directory. It's not anywhere, so you can't actually Ctrl-Shift A anywhere. So you have to instantiate it via code. To do that, you use the preload function. This preload function will take in a path from your project folder. Now, what you want to find is a path towards your game over screen that is stored in your scene's user interface or game over screen. I screwed it up, sorry. My user interface is not supposed to be here, it's supposed to be here. Yeah, it's supposed to be under scenes. There you go. Okay. Then I need to edit this, sorry. So this is going to be the game over scene, and now it's in the correct path. Okay, this is going to store a template. When I die, I want to instantiate it. I want a copy of this template of this class. Die, I will now take the variable and I will create an instance of it. This instance will be stored in the variable, and then we call it game underscore over underscore screen. It's more in snake case, lowercase snake case, because it's going to be an instance of it. It's an object, so it's lowercase snake case by convention. And this is going to be an game over screen, which is the variable, the template, the pack scene, and it's going to dot instantiate. This function will create a object. It's like in Java, it's called new. And now I have this object, right? It's not added into the scene yet. To add it, I need to define whose parent is it. And the parent will be the game scene. Notice that this player, right, will add the child, or will add this scene. But you want to add it towards the game scene. So this scene, right, should be here. To do that, you will have to get the player first, or get the parent first. So you get parent. You know that when you get parent, if you're instantiated here, you will get the game. And then when you get the parent, you dot add child. Child will add a new node underneath it. And this will add the game over screen, which is a node. And then you're done. Okay, you can play the game. Try to die. And I hope that's not loud. And I screwed it up because it's not at the it's not at the correct position. Okay. But I don't think I have enough time to fix that. I will show it next time. And I'll fix it and I'll put it in the GitHub. Okay, so that's the end of our class today. And yes, it's a lot to take in. And therefore, in order to finish the game, we need another day. That's why I planned it for 2 days. I'll also do a recap for anyone who is coming tomorrow only. And yeah, hope we have learned a lot. If you, yep. And this will help you in many different projects and modules to come. So thank you, and thank you to those in Zoom.
Hey, Brandon.